So now in the previous class we were discussing about analog to digital converters, right, and digital to analog converters. Fine. And again in the first module we have discussed about some more concepts like Ohm's law and adjustable voltage regulator, and what else we have discussed, different types of DACs and different types of ADCs. So all those things we have discussed. Okay, still many concepts are left out in the first module, but why I am switching to the second module, because the labs will be starting very soon. Okay, so without the knowledge of the digital electronics I cannot start the lab, so therefore I am switching from the module 1 to module 2. So in the module 2 few topics are done, okay, only few topics are done. Rest of the topics will be covered little bit later. So half, you can consider as half module from the first module is completed. So coming to the second module, okay, don't worry about the coverage of the syllabus. Okay, you just be interactive what I am teaching. Fine. So coming to the digital electronics, that is coming to the second module, we will be completely dealing with the digital electronics. So as I have told you well before, so what is meant by logic gate? Okay, a logic gate is nothing but a fundamental block. Okay, a fundamental block. If you want to build any of the circuit, okay, that will be acting as a fundamental block. Which one? A logic gate. Okay, so that gate, that logic gate, okay, logic gate is a fundamental block in order to build any of the circuits. So which will be having one or two inputs, which is having one or two inputs, one or more, okay, cannot write it as two, one or more inputs, and single output, understood? So logic gate is a building block in order to construct or implement any of the digital electronic circuits, okay, and the definition for the logic gate is a logic gate is a gate which is having one or more inputs but a single output. So the best example for the logic gates I have already discussed in the lab session yesterday. So the basic gates. So what are all the basic gates that are available? So basic gates. What is a basic gate? I think if I write there you will not be able to see, right? Okay, basic gates. So the basic gates are AND, okay, NOT gate and OR gate. I think you know about these things because you have already studied in the basic electronics in your first year, right? So the AND gate, NOT gate and OR gate. So these are the basic gates, okay. AND gate will look like this, okay, so which will be having the two inputs and a single output. AND gate will look like a D, a capital D, okay, this is AND gate, okay. Coming to NOT gate, how NOT gate will look? NOT gate will be looking like this, okay, a single input and a single output. So and again the OR gate looks like this, OR gate looks like this, which is having two inputs and a single output. Okay, why I am discussing all these things are, so these are the basic gates, okay. So and again there are derived gates, and again there are many other types of gates are available. We will discuss little bit later. Now, so logic gate is having one or more inputs and a single output. So if you observe all these gates, only single output is there and many inputs. There are three input AND gates also. Let us not discuss right now. Okay. So now I was telling that you will be having, the gate will be having one or more inputs, right? So what type of a data you have to give here? Can you give 2.5 volts here? Can I give 1.5 volts here? No, that is not possible in the terms of a digital logic. So you should give either a logic 1 or logic 0. Okay, you can either give a logic 1 or logic 0. So logic 1 is always considered as, okay, logic 1. Shall I write it here? Okay, logic 1 is considered as high, okay, and logic 0 is considered as low. Okay, logic 1 is considered as high and logic 0 is considered as low. And again logic 1 will be always 1 if it is connected to the 5 volts, and it will be logic 0 if it is connected to the 0 volts. I I repeat once again. So you cannot give any analog value here. You have to give either logic 1 or logic 0. Logic 1 can also be called as high and logic 0 can also be called as low. So when you are using high and low, whenever you are connecting the particular input to 5 volts, then it will be high. Whenever you are connecting the particular input to the ground, that is, it will be 0 volts. Okay, only these two values, either 1 or 0, you can give. You cannot give any hexa values or decimal values, okay, or analog value. You can give only a logic 1 or logic 0. So this is a brief introduction about what is meant by logic gate and what are the different derived gates, sorry, what are the different basic gates available. Fine. Okay. So we shall come back here. So the principles of the first important concept in the module number 2 is the principles of combinational circuit. Okay. So I cannot directly go to the techniques like K-maps and Minkowski methods. So before that, you should understand what is meant by a sequential circuit and what is meant by a combinational circuit. So first we shall discuss what is meant by a combinational circuit. Okay. So when a logic gates, okay, you know what is meant by logic gates, right? So that's why I have just explained. Okay. So when logic gates are connected together to produce a specified output, when the logic gates are being connected together or in a specified format in order to get a specified output for a certain specified combination of input variables with no storage involved. Very simple definition. If you are adding, it will be very difficult. Try to understand each and every word in the definition. So whenever the logic gates are interconnected in order to get the specified output for a certain specified combination of input variables. If you are giving whatever you want, if your input variables are something, if it is not related to the output, then you will not be getting a specified output. So if you want to get a specified output, you have to give a specified combination of input variables with no storage involved. This is very important. There is no storage element in the combinational circuit. But in the case of sequential circuit, there will be a storage element. That will be a different case. We will try to understand a little bit later. Okay. So right now, what is a combinational circuit? It is a collection of the logic gates which are interconnected in order to get a specified output when a specified combination of input variables are provided to it with no storage involved. This is the definition of combinational circuit. And the block diagram or the functional diagram of a combinational circuit will look like this. Okay, there are inputs and there are outputs. That's all. So all these things, the arrow marks that whatever I have written is the inputs to the combinational circuit, and whatever the outputs that you are getting from the right side, that is the output variables. So what it is there in the combinational circuit? So what, according to the definition, what it is a collection of logic gates, right? So there will be many gates like AND gate and it may be NOT gate. So like that, some structure is there within the combinational circuit. So for that, you are supposed to give the inputs. So what is the inputs that we are giving here? X0, x1 till xn minus 1. So n input variables. Towards the left side, it is described as n input variables. x0, x1, xn minus 1. Okay, so this is a general diagram. So it is having n number of inputs. Coming to the right side, so the outputs are y0, y1 and yn minus 1. So these are the outputs that is coming towards the right side. Okay, so now can I write it as y is equals to f of x? I am representing this combination circuit as f. F is nothing but a function. Function is nothing but a set of logic gates which are connected. Okay, in order to perform a specific, in order to provide a specified output. Okay, so therefore, can I call this whole terms y0, y1, yn minus 1? Can I call it as y? I'll be calling it as y, and x0, x1 till xn minus 1. I'll be calling it as x. So y is equals to function of x. Okay, so this function we'll discuss later. What actually the internal circuit is there, all those things we'll discuss a little bit later. So right now, the function or the output is just the function of the input variables. Okay, so that's why the equation is all about y is equals to f of x. Understood? So just copy down the definition of a combinational circuit along with the simple block diagram. So in this video, what are the things we have discussed? So what is meant by logic gates and what are the inputs that you will be providing into the logic gates, and what are the different basic gates are there, and again what is the definition of a combination circuit and a simple block diagram and the equation. So this much we have understood in this video. Okay, just write down all these things in your notes that whatever you have kept for ADE. Thank you.